Shall I start? Okay, well, hello everyone. My name is Savvas. Okay. Hi, my name is Savvas. Some of you might recognize me as the other Greek guy from Shazam. We had Jordan earlier in the day presenting our Android Wear. I chose to wear a lighter blue t-shirt so you can tell us apart. After some helpful feedback from my friend John, who did the unit testing talk yesterday, I decided to change the name of my talk. Because even though the content hasn't changed, this talk is mostly talking about how we solve this particular problem of preventing analytics and ads from polluting our code base using a library that we developed in-house and open source. So this is mostly presenting how you can use this library to help you with these two problems, but also you can use it for anything else that I will explain with how it can help you solve these problems. So yeah, this is now called the library Android lifecycle annotation, and you will figure out in a bit why. You can find me on Twitter at the geeky_android. And let's start with a question. Who here had to implement some sort of analytics in their app? Like page views, okay, clicks, stuff, okay, many of you. How many of you had to implement ads in their app? Okay, surprisingly not many, but who had to change ad providers after they've already implemented it? There you go, a couple of people. How many people hated that process and wanted to keep their, yeah, it was, okay, 2 people, all right. So we changed our app providers, I think, I can count 3 times off the top of my head at Shazam, and the change to the new app provider took us less than a day to implement and a couple of days to test manually first. And I'm going to show you how we've done this, how we've made our code base so that the ads and analytics of code doesn't mix in with our business code. We did that by realizing that these 2 concerns are cross-category concerns. They are things that apply across your app. You know, you have 10 screens in your app. Many of them will have ads, many of them will have analytics. So this is a cross-category concern, and this shouldn't be taking part, at least not a lot, in your actual code that defines what this activity does. So how we do that with on Android? We are engineers, we love reinventing the wheel. So we basically decided that we're going to take an old idea and bring it to Android. That idea is called aspect-oriented programming. How many people here have heard of that term? A few people. It's a very scary term. People tend to be very put off by this idea because it leads you to magic code and very difficult to maintain code. But if you limit it to those cross-category concerns, it's actually very powerful and very helpful. Another question, who here had to extend multiple activities at some point in their development? Okay. Isn't that lovely? You get this lovely problem. Look at all the 3 diamonds. You get the diamond problem. You have 2 activities that have some behavior, and you want to inherit both of those behaviors. And of course you can't because we use Java, and Java doesn't allow you to have multiple inheritance. So we want a way to get this behavior into reusable components that you can apply as you wish on every activity. And first you can combine them. We developed this library in-house. It's called Android Aspects. The name is not very sexy. We might decide to change it, we'll see. It's very early days, it's still in version 1.0. Hopefully if we get some feedback from the community, we can take this in a new direction. You can find it here, the link, you know, all the slides will be posted online so you don't have to copy it. But basically what this allows you to do is create objects that can be attached to an activity or a fragment and receive lifecycle callbacks from the activity or fragment, without having to extending another base activity. This will allow you to create, as I'll show you in a bit, reusable components you can just apply to any single activity you want. And we'll do that with a sort of live demo. It's not slides. I hope that doesn't scare anyone more than it scares me. Live demos always go bad. So here we have a very simple activity. It has 1 button on it, and you set a click listener on it that launches a new activity called second activity. There's nothing interesting in it. But as you may have noticed, I have this annotation here. Basically, this annotation called aspects takes a list of classes that implement an interface called an aspect. And those objects will be instantiated and receive all the callbacks that this activity will receive automatically. You do have to do this crazy extending one, that's an activity, It's kind of ironic because the purpose of this library was to stop people having to extend custom activities, but unfortunately it's Android, so you can only go as far. But hopefully this will be the only and the last activity you will ever have to extend if you decide to use this library. What this does is literally, the simple page view class is an implementation of an interface that receives the onStart and onStop callbacks. You may notice we don't call super here because this is not in the actual hierarchy, the object hierarchy of the activity. This is just an implementing an interface. And here we do a very simple page view on the onStart of the callback. We get the current time, and on stop we basically say, hey, I got a page view and it lasted this long. I will do a very quick demonstration of how that works. Right. The resolution is smaller than I was expecting. There you go, you see a message here that says the activity started. You can verify that there is an activity. If I start a new activity, you will see another line that says another activity started. Then you get the stop callback. This reordering of events is due to Android's way of handling these callbacks. On stop gets called after the onStart of the new activity has been called. I'll show you in a bit how we can fix that. But you can see here it also tells you how long this page view lasted. It lasted 12 seconds. Now that's pretty cool, you know, without any additional code, I've added a page view, which is this single piece of code. This is also applied in the main activity, as I've shown already, and in the second activity. Here, I have done something slightly different. The aspects library will allow aspects to be inherited. So if you have an annotation that is also annotated with an aspect, you can use that custom annotation to reuse that aspect. And I will show you in a bit why that can be powerful. But this is literally a simple annotation that has the same piece of code that the main activity has. Now, using this single line, we made two activities inherit a page view without writing any code. But that's not very helpful because you don't know which activity got started and stopped. You have no context around what happened. So next, I'm going to talk about the static configuration of these aspects. Oops, no. Right. So yeah, aspects are a bit pointless if they cannot be configured. Using that custom annotation that I've shown you, you can now add methods on that custom annotation, and you can provide static configuration for it. The annotation that I showed you before, the with page view, now contains a single method called page name. And that returns a string. So whenever you use this annotation, you have to provide a string to say what the name of the page is. Here you can see usage of it in the main activity, like I displayed before. Now we say this activity has a page view, and its name is main. The same goes for the second activity. The name of the second activity is called second. And on the aspect, that's something a bit more involved. When it receives the onCreate callback, it tries to fetch the attributes from that aspect. It does that using reflection at this point. We have in our plans to release a version of this that does code generation as well, because we know many people do not like reflection, even though we haven't found any appreciable performance issues with the way we use it at least. For now, it uses reflection to pull these attributes out and find what the name of the page in this case is. And then it does the same thing. On start, it gets the time that the page you started, and on stop, it tells you that the activity with that page name is stopped. This time, we will get a bit more useful information. There you go. Now we have the activity main that started. That started the second activity. The activity second has started, and the main has stopped, and it lasted 4,999 milliseconds. Now, of course, this is very simple implementation of a page. Like you usually use a third-party library, like Google Analytics, or you implement your own, or God forbid, you can use Flurry. But you can see how basically this might be used. With a single line of code, you can attach behavior to your activities, and they don't even know that something like this has happened. Now, this is also kind of useless because the problem with this is that you don't have many static pages in your app. Like some of them are, usually you have a home page that always displays the same thing, but for an app to be useful, you need some dynamically loaded content in it. Now, the dynamic configuration of aspects can easily be done with a trick. So, it's the same annotation like I had before. I've abstracted an object here. Instead of giving it a string, I created an object that defines the page, so you can attach more information to it if you wish. And this is how we do this. This aspect now looks for this specific page object, and you can add attributes to it as it receives the callbacks. So in our case, we have our aspect look for a specific interface in our activity. Here, we created an interface called pageViewConfigurator. You can actually provide its generic type, as you can see. You can specify the name of the page you're providing. That forces you to implement this method. You receive this callback when the page is about to be sent. So at this point, you can add any information you want about the page that was viewed. Now, the main page in this very simple example that I've displayed is still static, it doesn't really do anything. Apart from the fact that when you launch the second page now, you add some attributes to it. So imagine the second page as a page that displays the results of a track. For example, we load a music track, so assume that you have some random string that defines the idea of the track. We pass this here, I've done something very simple. I pass it through an intent, and the second activity gets that intent. The page of the first activity doesn't do anything fancy. I haven't spoken about this yet, I will in a bit. The second activity now uses that, parameter to pull out the track ID, and of course here you will do some loading of that track. But when you receive a configured page callback, you can now tell to the page, by the way, your track ID was this. And the implementation of that is a very simple object that contains a hash map of key value pairs. And the aspect looks for a map of those and it adds them to the page view. The way I implemented it is I literally just print out all the parameters that I get. On Google Analytics, these would be keys that you put in a map that the Google Analytics framework uses. It's very simple. Now, load. There you go, we have a page view that started, and the name is main. If I load the second page now, you see that the second page, I've already added it when you leave the page. So yeah, there you go. So when the page view of the second screen finished and it was being sent to your server, we now have these extra parameters. The duration came automatically like it did before. This behavior is shared between the two screens. This is only added on the second one. Now, about that other parameter I have here. You can configure these in any way you want. In this example, I've created a strategy that tells you when the page view starts and when the page view stops. This is again part of the static configuration that I've shown before. Because, as I said, Android calls on start of your second activity before on stop of your previous activity has been called, you can control it. So the main activity now has a strategy that says, I want this page view to come from my resume to my pause callback, and in the second activity, I don't specify anything. You can do that in annotations. I don't know how many of you have used annotations, but when you provide these methods, you can provide default values. This is literally a simple enum. I've only chosen start, stop, and resume pause. But the aspect, in this case, will look for that method, find the specific enum that you provided. By the way, hashtag, I use enums. I don't know how many of you use enums. No? No one here, right? Here you go, one person. The way this works is you on create, you pull the attribute, you find the strategy based on that enumeration. We have a factory here for the strategy, but this is basically this is giving you an object that literally implements either the start of the page view in the on start and on stop, or in on resume and on pause. And you delegate all these callbacks to that strategy. So now the implementation of these, we have the start stop activity page view strategy, which calls the session manager in on start and on stop. The other thing you might notice here are all these classes have nothing to do with Android at this point. You can unit test this, even though I wouldn't recommend you do that. Because this is, as I said, a cross-category concern. This is better tested from an end-to-end perspective. Like we have a UI tests in our system that check that analytics events happen as we expect them. We could test them in more of an isolation in the unit test or a sort of integration test level, but we find that having them on the top level helps us guarantee that the page is actually happening as we expect. Something else in your system might not be wired incorrectly. So yeah, but you could probably test them individually. These are normal Java classes, there's nothing angry about it. You do need references to the classes, like activity, but now with Android's JUnit4 support, we provide a mockable stuff basically. Android jar, you can easily write units, for instance. Now, how that translates to ads. Ads are very interestingly, very similar to analytics. Most of the ad SDKs that you use follow the same patterns. You have a view in which you basically give it to the SDK, which adds its own views internally, container basically. And in order to configure that ad, you need to give it some key, which is sort of like, it's called the site ID or the zone ID, depending on what SDK you use. And you also have to give it some keywords to configure the type of things that you're displaying so that it can do some targeting. So if the user is, I don't know, viewing a Madonna track, you might give a key into your ad network that says artist name, Madonna, and if there's a Madonna-related ad being trafficked through the network, it will get delivered to the user. So in that sense, it's very similar to the ads, to the analytics, in the sense that you have to set up something, configure it with a value, and then dynamically add things to it. In the analytics portion, it will be the name of the page, which is statically defined. In this case, it's the zone IDs or the site IDs. And the dynamically configured content is the targeted parameters that you give to the ad. Now, I've completely faked this by not actually using any real ad SDK here, but by creating my own, which is a dummy view that displays whether an ad has been loaded or not. Here, you see an activity, and when you start it, we have a red thing. There you go. The green indicated that an ad loaded. This ad ID is the site ID that is with. This is statically defined. Now, the way this is done is with another custom annotation, which is only appended on the second activity at this point. You say with add. You statically define the name of the page, like before. And the aspect itself, we have an add binder aspect. Here we use convention over implementation, configuration, yeah. Basically, we assume that the aspect will try to find a view on your hierarchy that has a specific view ID. We specifically here look for our ID output. You can, of course, make that a configurable parameter in your aspect. Here, you find the view in on resume. You configure it using the ID you just found from the annotation, and you load the ad. That's it. Everything else is exactly the same. This is the static version of the ad, and when we go into the dynamic version, it is a very similar situation like with the analytics. Now on our activity, we also implement another interface called Ad Configurator. This gives us an interface, and we dynamically load. In this case, I pass again the track ID as a parameter, but here you could put the name of the artist, like I said, or anything else. And this, of course, propagates through the ad facade into the actual ad SDK. Here is where you would use your SDK's implementation of how you can add parameters to it. Here I have a very simple, I think this is a map of some sort. This is the actual texture, so yeah. I set, I only display the keyword that you display, that you dynamically loaded. And to demonstrate this, I will load this version of that. Start a new activity, and as you can see, now we have a dynamically loaded key configured into the app. Now the use of this might not be easily apparent, but imagine an app that has 20 screens, and every screen has a different site ID, and every screen has a different way of providing these keywords, and now you can start thinking about how you would have to duplicate this piece of code into all your activities, or you would have to create a base activity, and then of course you run into the same diamond problem that if that activity also requires analytics, now you have to make all your activities that have ads also have analytics, or vice versa. Here you have the option of this activity has an ad, it also has a page view, but the main activity only has a page view. And you can keep stacking them up, create as many as you want. Lastly, I want to talk about user-initiated events. So Here I want to talk about a bit about how we structure our views in relation to our business logic, because this whole talk, again, is about how you separate those two concerns. This is a very contrived example, just to demonstrate the fact that we use some sort of MVP, like hopefully most of the people here do. We create our presenters in our activities, in our views in this case. We pass the instance of the activity as a view. That's an interface, as you can see here, called main view. It has one callback, but the tracks that we want to load have been loaded. And we have an abstraction that loads things. We call them fetchers, where we're considering changing the portion of this the presenter in our apps. But for now, that's how we do it. We have an implementation in Android that uses loaders internally, but the presenter is an interface that tells it that it needs to fetch some data. In this case, we're fetching a list of tracks. That's how the presenter looks. Our presenter is pure Java code. This is unit tested. This is TDD. This is driven by tests. When you start presenting, we fetch the tracks, and when the tracks have been fetched, we tell the main view to display them. This is how we do this. You also can, of course, react to callbacks that failed. You can also react to the main activity events that are being clicked or something like that. This is a very contrived example just to show the main split. Our views, which are activities, do not contain any business logic. We strive to make all our activities be as simple as possible with no branching. There are no ifs, there's no complicated business logic. We might sometimes do some view-related logic, like if you receive a view from Android, you have to check for nullability. Sometimes you get this weird callback. There's a callback called a new intent, which might sometimes give you a null intent, which is very odd. So things like that are very specific to the view we might check for. But we're not doing crazy things like, oh, is Google Play services available? We don't do those things in the views. We do them in the presenter by using business classes. And here, of course, this loads a list of tracks and it displays them. It has an adapter, and the adapter is literally just giving you a list of track IDs. Now, when you launch those track IDs, you display the details of said track. I'll demonstrate how that looks first of all. So I'm faking a slow network code here. There you go, we have a list of tracks with a button to buy the track. If I click on one of the rows, I'm launching the track ID, that's the specified track ID, which then loaded the track title. Same thing goes with the ad, I haven't changed anything there. But you might notice that we have a buy track button in both the screens. This is the same view. Now, when this view is bound to the data that it's supposed to display, we call this method bind to the track. The model in this case of the bind method is an object, it's a simple ring, it's called track. It contains the track ID, maybe the name or something related to that. And it might link you to, when you open this, there's a click listener here that launches the new click listener. And yeah, when we buy this track, we say that we buy something. This specifically, that's the adapter, sorry, that's the adapter click listener. And in the tag row, there is a buy button, there you go. And this buy button, when you click it, sends an event. This would be a user event in our case. We're using an abstraction for event analytics as well. We never use the third-party library directly. You should never do that. We usually use Flurry for our analytics, and then we decided to do all our event tracking in-house. So we only had to change an implementation of the class, and everything worked, more or less. That's what it does. But because this is configured only with the data of the track that you're supposed to buy, it is kind of useless in the sense that it doesn't provide you the context of where this data came from. Let me demonstrate what you do get with the code that I've written so far. If I press on the buy track here from Smells Like Teen Spirit, I will see an event generated, it's a user event. The track ID is that track ID Smells Like Teen Spirit, and the event type is buy button click. That's cool, but if I open the screen now and I buy the track again, you will notice that the event, whoa, I pressed it too soon. There you go, the event is exactly the same. Now, this is okay, and if you have a data team that, if it doesn't have to go through a lot of data, or that has the time to generate reports on a weekly or monthly basis, that's okay, because you have the context of the page views in relation to these user groups. So you can say, oh, the user pressed the screen to launch the details of Smells Like Teen Spirit, and then press the buy button. So you can infer that the user pressed the buy button in that screen. versions on that list. But in our case, none of these two requirements are true. We have a ton of data that are constantly adding to our system. And our reports, most of the time, have to be real time. So we have graphs that whenever we release a new version, for instance, we can track the behavior when we do A/B testing or something like that. We want to basically see the effect of a change in the UI on how that has changed the behavior of the user. So for that reason, we are often asked to provide some context around our events. So which screen did this happen in? Or what was the user doing before that screen was launched? In the past, we used to do this very manual thing of saying, okay, so now the buy button, when it is bound to some data, it's not going to get just a track that it needs to display, it's also going to get the name of the screen that it was on, which works, but then of course you have to pass the screen down to your presenter so that then it binds the data back into the view. So now you're basically polluting your domain model with stuff that are completely unrelated to that domain model. For that, we found a workaround. It's a bit of magic, but it works very well for these specific context-related events. And I will demonstrate how we do this. Every time I show this to a new person, the first time I show this to someone, they usually cringe. They think it's a bit over the top. But when you actually use it a lot, it's, the value becomes very apparent. So, we have this aspect. Now, this aspect is looking for the page view aspect. So now we're talking about aspects working together with each other. So when this aspect is attached to an activity, it will try to find the page view aspect. If it finds the page view aspect, it will find the name of the page, of that page view, and it will attach it as a tag to the root of the hierarchy of the view. As you may know, the Android view class has a set tag method that takes an ID and any object. So we do that, where we basically store in the root of your hierarchy some data that are related only to events. That's cool. The second part of that is, so now when you use an event analytics object now, we don't use the same interface as before, but we have an interface that takes a view as the first parameter. So it takes a view and an event. The implementation in this case will try from that view to go up the tree of its parents until it finds one of those tag objects. And if it does, it will attach any information that they contain back to the event analytics that was generated here. So without actually letting the button know which screen it lives on, it will get that information and it will add it to the parameters of that page. Sorry, that user name. Let me just demonstrate. So now when I launch the buy track for the Smells Like Teen Spirit, I will get an event that has a screen name called main. That screen name was not added on the buy button, it was inferred from that other aspect. And just to demonstrate, of course, if I launch the details page, and I do the same thing, now the user event contains the name of the second screen. Now, I hope this is, like the use of this is very obvious. It has helped us immensely. We used to obsess about we kept worrying about our product people asking us to add a new piece of information to every user event that we generated, and every time they did, it took us like a couple of days to make all our tests take that parameter into account. It made our tests very brittle. We didn't want to have to deal with that. Now we don't. Now everything is automatic, everything is magic. The problem with magic is that if you use someone else's magic, it's very scary because when things go wrong, you have no idea how to resolve it. In this case, this is an internal library, so we're very familiar with it. Take that with a grain of salt, that if you think you can have some usage for this, it is obviously not maintained by you, but it is an open source project, and of course we are very reactive to comments about it. Now this is the portion of the talk about these specific ads and analytics. But getting back to my demo, my slides, I would like to talk about basically what you should take out of this presentation. Aspect-oriented programming is very powerful, but it's very dangerous because these things can get really out of hand really quickly. You have to target it to specifically the cross-cutting concerns that have nothing to do with your business logic. Now, we may have I think we had to actually move some piece of functionality from an aspect back into the domain, because then we realized that it was actually not cross-cutting zone. I can't remember exactly what that was, but I seem to remember that we did. But the moving some code back into the business logic is not actually very difficult. It's literally a class. So instead of using that class in an aspect, you just use it in your presenters. The code is still the same. It's just that where you invoke that code from changes. And of course, for, as I call them, uber cross-cutting concerns, things that should span the entirety of your app, you can use the Android system, because Android does provide you with a mechanism of attaching objects to lifecycle callbacks, but only for activities. And the downside of that, using the application register activity callbacks method, is that the object that you register will receive callbacks for all the activities. So they're not targeted to a specific activity. You can cheat, of course, and you can get the incoming activity and check that it's the instance of the activity you're expecting, but then you're getting into the world of magic again, and you might as well use something that is already tested and used. The other problem with this is that, of course, you can't use it in fragments. Now, the aspects library that I talked about works with the fragments as well. You can create an aspect for an activity, an aspect for a fragment. Those two aspects can use the business classes, the same business classes, and you can have a custom annotation that uses both those aspects, and you can use that custom annotation on any activity or any fragment you want, and it will automatically find the right aspect that needs to be applied. So the page view aspect, when we use it, does page views both for activities and for fragments. And for some activities that have no fragments in them, we started writing those. If an activity is very simple and it displays one piece of information, we do not attach fragments to it. So we have the page view annotation, we put it on the activity. For our main activity, where we have a view pager, where we have like 3 different fragments of pages, we annotate the fragments themselves, and the pages work automatically. It's the same annotation. Speaking of which, how do we use this for anything else at Suzanne? As I said, we use it for pages and for ads. When we had to change, again, our ad analytics, we only had to change the implementation of the ad binder. So just use a new provider and everything works. The implicit user-read parameters, like I said, attaching screen name and other context information. We also have some magic to tell you which screen you came from when the event is generated in the new screen, and we use some magic through our intent system to get the information and attach it to the roots. The fab. Now we started implementing the fab floating action button, for those that do not know. We started implementing this before Google released their support library and the design library, now they call it. But now we have an annotation that works well in fragments and on activities. If you annotate an activity or a fragment with the fab annotation, you get a floating action button, which is the Suzanne one. It's branded, it comes in automatically. When you tap it, it starts the recognition process. And it also has automatic bindings to recycler views, scrollable views, so that it can hide itself when you reach the bottom of the screen automatically, so that you don't obscure the last piece of information. And all that happens in one class, which you can annotate with one line and get fab in an activity or fragment. Now we do have that as an aspect, because some activities we don't want to have a floating action button. But if we want it across the app, of course, you can use the application the register activity lifecycle callbacks that I demonstrated before. We also have an aspect for running the hierarchy viewer server by Romain Guy. I don't know if you guys are aware of this, but to attach the hierarchy viewer on a production device, you need the server running on the phone. It's a very simple server. You literally have 3 callbacks that you have to do on start, on stopping, and destroy. With the aspect, you just say a hierarchy viewer, and you suddenly have a hierarchy viewer running on that activity. This is only for debugging purposes, of course. And we always come up with more ideas why we should use this. Now, this is sort of a cheeky way of me to link to another library that I wrote. Another example of this is Butterknife. Now, we're considering using Butterknife. We haven't actually made the switch yet. Butterknife is very nice for view injection, so you don't have to say find view by ID that, find view by ID this. But they neglected, not neglected, I don't think the framework will allow you to do this. So this is how you bind an activity with Butterknife. So you say set content view, you set your content view, and then you have to bind the Butterknife to this. That's the good case. On a fragment, you have to create a view, and then you have to register the view on the fragment. It's a bit more complicated. And you also have to call, I think on the fragment only, something on the store. I'm not exactly sure, I can't remember off the top of my head. But this is perfect for this aspect library, because this is some behavior that needs to happen on create, and it has to keep happening for all of them. So this is a cross-cutting concern. And this is a very good example of how you could write a custom annotation like this. So now you annotate your activity with bind layout. You provide the layout as the value of the annotation, and it automatically binds it. This also works for fragments, the same annotation with the same value. Internally, we have two aspects, one for a fragment, one for an activity, and the system finds the one that it needs. And based on the implementation of your class, it will find the right way to initialize button. This is open source, it's published. I just haven't pushed any artifacts into any repository, so if you want to play around with it, you will have to build it locally. I have some instructions on the GitHub page. Now, of course, I also have the, that's not what you want. Okay. I also have the code that I just demonstrated on the public repository, so you can download this. It's tagged, every portion of the example has its own commit. All these, of course, will be shared with the slides at the end, so you don't have to worry about copying this URLs. Yeah, I hope this talk was helpful. I hope you found it useful. Even if you didn't find it very useful, have a play with the library, and if you have some ideas about any other aspects that might be used and shared with the community, let me know. And please start it, fork it, write your own, and let me know about them. Thank you very much. Any questions? You do? Okay. Any questions?
And just one question. What about the edge case when you click on the button, you press buy, and you have a bunch of providers, let's say Google Analytics, Flurry, and so on. And for Google, for one provider, you have a different set of parameters, and for another provider, you don't want this, for example, adjust.io to be sent to this event.
Would you have both the providers running at the same time?
Yes.
Well, then you can, because as I demonstrated and go back to the code, the way, so the way that in the end the page view is created is through this aspect. This aspect creates strategies, right? So the same way that I've created a strategy to decide which method calls start and stop the page view, you can have a filtered version of that. So you could have an annotation, for instance, in this type of the page view, and you can say stuff like, I'm going to keep it very simple. There's probably a more clever way to do this, but you can have programs to exclude from Google Analytics. Right? Now, actually, the default value, default image string, enter. No, 0. Sorry? Yeah, it's an interface and you can have it. There is a way, I think, you can implement it, I think it's a constant you can do it, but you can specify, I think it's about index. So yeah, it depends on how you define your model. Like in our case, the keys that we provide, we have a dynamic way of providing them, but we also have a list of specified keys that are always the same. So for those, we have an enumeration representing them. So you can have a list of enums here, which of course I'm not going to create at this point, but you can have a list of enums that denote the keys you don't want for Google, for instance. Default is going to be empty. And now in your implementation of the page view manager, you can get that from the annotation and say, okay, that's the map that I received, have any of these, I'm the Google one, I'm just going to ignore them. And the Flurry one wouldn't ignore them. And that's one idea. The other way, like if you only have a Flurry in one screen and Google Analytics on another screen, so they're separated, then the solution will be much simpler. You have two different annotations, of course. That's much more safer. I hope that answers your question.
Yeah, probably.
Oh, thank you. Any other questions? Oh, no, okay, well, thank you very much.